Hello everyone, today I'm presenting our project on the Chinese language knowledge map, an end-to-end pipeline for career-driven Chinese learning. Our central question, how can we help learners study Chinese for specific career goals? We built a system that defines and classifies Chinese vocabulary, constructs a knowledge graph connecting applications to language skills, and generates personalized, explainable learning recommendations. The project progresses through four objectives: vocabulary foundation, word classification, knowledge graph, and the recommendation engine. The presentation flow follows this sequence, culminating in validation and conclusions. Objective 1 establishes the data foundation for the entire project. We curated 580 seed words with rich metadata, HSK level, post domain classification, example sentences, and KG identifiers, and created an extensible schema supporting over 11,000 candidate word profiles. Our data comes from multiple sources: HSK for proficiency levels, CWN for linguistic properties, ONET for occupational mappings, MOOC CubeX for course candidates, and Crosswood for real task-oriented dialogues. The key deliverable is the presentation table, linking each word to topics, communicative functions, scenarios, courses, and examples. Objective 2 adds an explainable multi-label classification layer on top of the vocabulary. We classified all 580 words into 10 learning categories using a two-tier taxonomy. Tier 1 covers linguistic attributes, HSK level, pose, discourse connectors, idioms, and set phrases, and rhetorical devices. Tier 2 covers learning and applications, conversational Chinese, general reading, writing, professional workplace communication, academic writing, and domain-specific topic vocabulary. Critical design principle: every classification each records its rule source, evidence, and confidence score. No black box. You can trace exactly why each word was assigned to a category. We generated 1,132 multiple label edges across 10 categories. Topic vocabulary is the largest, followed by professional communication, conversational, Chinese, writing, literary culture, academic reading, work writing, reading comprehension, discourse connectors, idioms, and poetic rhetorical devices. All 580 words passes coverage checks. Key limitations: literary scope is minimal, and 18 words retain unknown, posed to prevent unreliable imputation. Objective 3 transforms tabular data into a connected knowledge graph. 2,155 nodes and 9,475 semantic edges. Node types include applications, domains, Chinese abilities, words, learning categories, scenarios, functions, questions, and courses. Each type connects in titles by function, relevance, and the required skill. The entire graph forms a single connected component. Every node is reachable. We applied 3 network analysis: centrally to identify key hubs, community detections to find learning clusters, and path analysis and link prediction to trace routes and suggest new connections. Centrality analysis shows the 4 Chinese abilities: listening, speaking, reading, writing are the most central hubs. Validation that ONET occupational requirements translate directly to Chinese language needs. The topic vocabulary category bridges general lexical knowledge and career-specific learning. Community detection reveals coherent Chinese for specific purpose clusters. For example, a clear tourism Chinese community connects tour guides, hospitality vocabulary, dialogue examples, and practice questions. Path analysis provides transparent shortest passes. Tour guide to tourism domain to conversational Chinese, making every recommendation explainable. Link prediction ranks occupation toward candidates using shared domain and category evidence. Objective 4 builds the recommendation prototype, taking tour guide as an example. The system produces a ranked Chinese ability profile. Key communication genres like surveys, dialogues, and presentations. 10 HSK elegant learning topics with a full study plan, including vocabulary with pinyin and grammar points. 6 mood course candidates, and a practice question bank with function recognition. Vocabulary production and production task question types. Outputs are multi-format, JSON for developers, Markdown for direct learners use, and CSV for cross-occupation research. The engine follows an 8-step deterministic graph traversal. Step 1. Job match via keyword. ONET mapping. Step 2. Rank ability using ONET scores. Step 3. Extra communication generates from task statements. Step 4. Assign topics HSK level. Step 5. Select scenario sentences. Step 6. Enrich vocabulary with objective 2 multi-label categories. Step 7. Pick more courses by domain. Step 8. Build practice question bank. This is a fully rule-based, traceable prototype. Every output can be adjusted by following explicit graph edges. We tested 5 occupations across 4 domains: tour guide and hotel front desk, software developer, budget analyst, and operations manager. In total, 154 vocabulary words, 32 example sentences, 147 practice questions, and 30 course candidates. 3 of 5 occupations required fallback ONET mapping due to missing primary ability data. All 4 objectives form a coherent sequential pipeline. Objective 1 provides the data foundation, vocabulary profiles, domain taxonomy, and ONET mappings. Objective 2 adds the semantic layer, multi-layer label classification explaining how words function in learning contexts. Objective 3 constructs and analyzes the knowledge graph, centrality, communities, passes, and link prediction. Objective 4 consumers the graph to generate personalized, traceable learning plans. What works? 5 demos produce complete 8-step recommendations. 100% of words have objective to multi-label classification. All case tracer source used verified edges with 0 broken links. Question banks contain all 3 required interaction types. What doesn't work yet? This is a rule-based prototype, not a trained ML model. Coverage is limited to 5 demo occupations. 3 occupations require fallback ONET. MOOC courses are domain-matched candidates, not educationally optional. No out-of-sample validations against human expert labels. Future work: expand manually verified examples. Add professional corpora. Evaluate recommendation quality with learners, and compare against graph embedding or supervised link prediction models. Our projective delivers an end-to-end explainable pipeline for career-driven Chinese learning. Objective 1 gives the vocabulary backbone. Objective 2 adds transparent multi-label classification. Objective 3 constructs a connected, analyzable knowledge graph. Objective 4 generates personalized, traceable recommendations. The core value is explainability. Every recommendation can be traced along graph edges. This is not a black box. It is a transparent system for learners, teachers, and curriculum developers who need to understand why a particular word, topic, course is being recommended. Thank you for your attention. We are now ready to address any questions you may have.